Great. Hey, everyone. And thanks, Alex, for kicking us off. So as Alex said, this session is going to be focused on building GraphQL APIs with the Neo4j GraphQL library and Neo4j Aura, which is Neo4j's database as a service. All of the material for the workshop today is in these slides, which are linked at dev.neo4j.com/GraphQL-workshop. So if you want to follow along, there's links to code that we'll be using. So definitely pull these slides up to follow along as we go through this. So my name's Will. I work on the developer relations team at Neo4j. You can find me on Twitter. That's probably the best way to get a hold of me, at LionWJ. And then also my blog is linked there, where I write about lots of Graph and Neo4j related things, lionwj.com. And I also, along with my colleague Lou, host the graphstuff.fm podcast. So if you like podcasts about technical stuff and specifically graph database and Neo4j stuff, check out graphstuff.fm. So the plan for today, so we have 2 hours, and we basically have 4 modules to work through here. So if we spend roughly 30 minutes per section, then we should be okay on time. We may not get through everything depending on how we do on time, but all the material is available in the slide deck, which you have access to. And again, that's linked in the chat as well. And we'll take another look at it again. So make sure you have the link for that. So we'll talk a little bit about what is GraphQL, why would we use it, how do we use it, and then the rest of the session will be about building GraphQL APIs with the Neo4j GraphQL library, which is a Node.js, so JavaScript library for building GraphQL APIs backed by Neo4j. So we'll take a look at how do we use this library, what are the basic features, what does it give me, why would I use it? Then we'll take a look at adding custom logic with Cypher to our GraphQL API, and then we'll take a look at using some of the authorization functionality built in to the Neo4j GraphQL library. So this is a hands-on workshop, so you will get your hands dirty doing some coding. We're going to use 2 online tools, so there's no sort of local environment setup that you need to think about. We're going to use Neo4j Aura, and specifically we can use the free tier of Aura, so we don't have to put in a credit card or anything like that. We'll just spin up a free tier instance. And then each module has a link to a Codesandbox. Codesandbox allows us to run JavaScript code in the browser and even Node.js code in the browser, and gives us a code editor, kind of like VS Code. So you'll have a sort of starter link for each one of these modules, which will have some initial code, and then we're going to go through and add a feature, tweak the code, run some GraphQL queries, that sort of thing. So when you open the Codesandbox link, and we'll look at one in a minute here, you will be prompted to sign in with GitHub or email or something if you want to save your changes. And the reason for that is because that Codesandbox, once you make changes, is private to you. So that's why you're being prompted to sign in and fork those Codesandboxes. Okay, so that's the agenda. So here are some resources that we'll use. Some of these during the session today, some of these for later on. So again, the slides that we're looking at now, dev.neo4j.com/GraphQL-workshop. This is really all of the content for the workshop. And this will have the links to the Codesandbox snippets that we're going to start with, and the exercises as well. So if you want to follow along, definitely open up the slides as we go through that. The documentation for the Neo4j GraphQL library is available here. This will be useful as well. And then this is an overview page of the Neo4j GraphQL library that links off to things like self-consumable training, so the Graph Academy training, which is a bit more in-depth than what we have time to cover today, but similar material. The material we're going through today is actually borrowed from this Graph Academy training, which is, again, more in-depth, so covers more than what we will cover today. So this would be a good follow-up after today's session. And then we are only going to focus on kind of the back-end aspects of GraphQL today. We're not going to talk about how do I integrate GraphQL into the front end of my application, how do I use it with React, that kind of thing. We're focused today only on building the back-end API with the Neo4j database. But of course, it is important to understand and work with GraphQL on the front end as well, like in a React application, something like that. And to get you started there is the GrandStack starter project. So GrandStack is GraphQL, React, Apollo, Neo4j database. And this GrandStack starter project, which you can create with this npx command or clone from GitHub, this will get you started with a full stack application that has the React front end, the GraphQL API, and Neo4j database as well. It's like a business reviews application. So that's a good starting point for a full stack application, and again, is a bit beyond the scope of what we're going to talk about today. Cool. So I see lots of folks in the chat joining from all over the world, it looks like. That is great. So it looks like chat is working. So feel free to ask questions in the chat or let us know where you're from, what you're working on, that kind of thing. It's really fun to hear where people are joining from and what folks are working on. Cool, so let's jump in here. To start off, let's talk a little bit about GraphQL, what it is, why I would use it, how I use it. So first and foremost, GraphQL is an API query language and a runtime for fulfilling those API queries. So with GraphQL, we have a strict type system that specifies the data that we have available in the API, including what entities, the attributes. In GraphQL terms, we call these types and fields. And then we also describe how these types are connected. So that's where the graph part of GraphQL comes in, is that in these type definitions where we're describing the data that we're working with in the API, we describe how these types are connected with relationships, and that's the graph of GraphQL. Queries then allow us to traverse this data graph. So at query time, the client expresses an entry point. Either a query, mutation, or subscription. We'll talk about those are in a second here. And then specifies some traversal through this data graph. So what fields do we want to bring back? And then only that data is returned based on what the client asks for. So some important concepts from the world of GraphQL. One is GraphQL type definitions. So we talked about this idea of the GraphQL type system, and we are defining the data available in the API, how that data is connected, and we've defined that using GraphQL type definitions. There are a few different ways to create GraphQL type definitions. Typically, we use this language called the Schema Definition Language, or SDL. And SDL is nice because it's language agnostic, so I can use SDL, and that's nicely to a GraphQL implementation in JavaScript, in Java, in Python, whatever. It's not specific to the language that I've used to implement my GraphQL API. You can, of course, programmatically construct these GraphQL type definitions, but I think SDL is the language agnostic way to do that, and that's what we'll be using today. So we talked about this idea of GraphQL operation being a query, mutation, or subscription. So when the client sends a GraphQL request, it's one of these three types. So a query, which is typically a read operation, mutation, typically a write operation, and then a subscription is kind of like GraphQL's pub/sub mechanism. So I can subscribe to certain events and then be notified when those occur. We're not going to talk about subscriptions today. We're just going to talk about queries and mutations. So that example on the screen is an example of a GraphQL query. And each GraphQL operation has a similar structure. So we start off with an entry point and any optional arguments for the entry point. And an entry point into GraphQL API is going to be a field on the query, mutation, or subscription type. So in this case, there's a movies field on the query type, and you can see the optional arguments that it takes here, which it looks like we're filtering for a certain movie by title. And the other component of a GraphQL operation or GraphQL query is the selection set. And the selection set, this is a nested structure that specifies two things. One, it specifies how we want to traverse through this data graph. So you can see here, we're starting with the movie A River Runs Through It. Then we're going to the actors connected to that movie, grabbing the title, or I'm sorry, the name of the actor, doing a similar thing for genres, traversing to the directors of this movie. And then this selection set is nested, and we can go arbitrarily deep in our traversal here. So for the directors, we're also looking at the other movies that these actors have directed and grabbing the title of those movies. And each of these field arguments will have each of these fields rather will have optional arguments. So here we're limiting, looking at the first two actors, looking at the first three directors. So you can think of the selection set as one, a traversal through this data graph, and then also as specifying the fields to be returned. So only the fields specified in the selection set are returned in our GraphQL query. And this is the data that comes back. This is a JSON object that matches the shape of our selection set. So we get back exactly the data that we asked for, exactly the fields that we asked for in a shape that matches the selection set. So we know exactly the structure that we're getting back from our query based on the operation that we specified. So another important concept to think about in GraphQL world is resolver functions. Resolver functions are the logic for actually resolving these GraphQL requests. So when I write a GraphQL query, there's a resolver function that's called for each field. And this is where the logic to go out and fetch this data from a database, or we can even wrap some other API. But these resolver functions are where the logic for actually going out to the data layer and retrieving that data, or if we're executing mutation, actually updating that data in the database, that kind of thing. You can see here, this is an example from a API looking at conferences and sessions, and you can see we're using an ORM-like API for going to a database and looking up sessions by title. And then once we have a session, we're looking for the room that session is in, doing a similar thing for the theme, and then fetching recommended sessions. So these resolver functions are called in a nested manner. So we start with the root resolver, which in this case would be the query field. And then based on the fields specified in the selection set, we call the resolvers for each of those fields, and so on. Now this nested structure, this can cause some performance implications in GraphQL backend implementations. If you think of each one of these resolver functions as making a request to a database, we don't want to be making a whole bunch of round trips to a database for each nested GraphQL operation. So if we go back to this query where we're looking up a movie, then we're looking up the actors in the movie, then we're looking up the genres, then we're looking up the directors, then for each of those directors, we're looking up what movies they directed. We don't want to go back and forth to the database each time that we're requesting data in that selection set. And so there are a few options for dealing with that. That's called the n+1 query problem, where we're making n+1 number of requests to the database, where n is, in this case, it would be like the number of movies or directors that we found. And for this reason, the Neo4j GraphQL library generates a single database query. So we won't have to be thinking about resolver functions. Those are generated for us by the Neo4j GraphQL library. So when we say here that the Neo4j GraphQL library auto-generates resolver functions for us, what that means is that the Neo4j GraphQL library handles generating the database query and the resolver function that goes along with that. So we don't need to actually write this kind of boilerplate code that's sort of fetching data from the database or think about the kind of performance implications of handling this n+1 problem. That's handled for us by the Neo4j GraphQL library, which we'll talk about in a minute. But resolvers are an important concept to understand in general with GraphQL. So what are some benefits of GraphQL? Well, this idea of overfetching, where we are maybe sending more data than what we need over the wire. So if we think of like a REST API where we have endpoints that map to resources, and a resource has all of these attributes, and we get all of those attributes regardless of what the view in our application is rendering. Maybe we have, I don't know, like a user profile information, and we have a whole bunch of information attached to that user profile, like address and I don't know, maybe what mailing list I subscribe to, these kind of thing. But if the view in my application is only rendering maybe like the username and my profile image, I don't need all this other information to be sent over the wire when I render that view in my application. And GraphQL allows us to say, okay, well, for this view in my application, I'm only rendering these two fields, so only return those two fields. So that's less data sent over the wire. And then I guess the cousin of that problem is underfetching, where I need to make multiple requests to the API to render all the data necessary for the view in my application. So maybe if I'm showing a list of blogs and their authors, first I get the blogs, and then I need to go back to the API to get the author information to display that. Maybe that's where the user profile information comes in. With a REST API, I may need to do that where I make multiple requests back and forth to load all the data for the view in my application. But with GraphQL, I can specify in a single request that I want all of the blog posts and also all of the necessary author information for each blog post. So that's overfetching and underfetching. Another benefit of GraphQL is that we have a clear GraphQL specification that is defining exactly what GraphQL is. So there's no kind of argument about what type of GraphQL or what flavor of GraphQL we're implementing. Something either is or isn't GraphQL, and that specification allows us to build lots of great tooling in the ecosystem to work with GraphQL. We've talked a bit about being able to specify exactly the data needed to render a specific view in my application. And this allows us to simplify data fetching in a more component-based interaction. So if I know that, let's say, a specific view component in my application is rendering the profile username and a profile image, I can attach the GraphQL query to fetch that in that front-end component. So that allows me to kind of encapsulate data fetching with the component that is rendering it in the view. And then really, I think there's this benefit of having graphs all the way down. So thinking in terms of how you're interacting with your API and your application in terms of relationships, because that's often how we think of data in our applications. And then there are a lot of developer productivity benefits with GraphQL. So we have the strict type system, so we know exactly what data is available and what that data looks like. And that allows us to basically have self-documenting APIs. There's a lot of interesting tooling that can be built on top of GraphQL as well, since we have this idea of the type system and introspection, which is another powerful aspect, which allows us to introspect a GraphQL API and say, hey, what are the data that are available through this API? And then build things like autocomplete or generated documentation for the API. So those are some of the benefits of GraphQL. There are, of course, some challenges as well. So these are things like a lot of the well understood practices from REST don't necessarily apply. So we have to think of handling HTTP status codes a bit differently. Error handling is a bit different. Caching doesn't quite work the same as it does in the REST world. We also have to think about, okay, if we're exposing arbitrary complexity to the client, are there performance considerations there to deal with? We talked about this N+1 query problem where the nested structure of our GraphQL operations can often lead to multiple requests to the data layer. We need to think of how to handle that. And then query costing and rate limiting are an interesting challenge where our GraphQL queries may be arbitrarily complex, so rate limiting then needs to take into account the complexity of the query. Now, there are best practices and tooling that address all of these issues in the GraphQL world, but these are some of the things that often come up when we're first looking at adopting GraphQL. So it's important to think about how to handle these things. Okay, so there's lots of great tooling in the GraphQL ecosystem. We're going to use GraphQL Playground today. GraphQL Playground is this in-browser tool that allows us to query GraphQL APIs and take advantage of this introspection feature of GraphQL that we mentioned to look at the sort of generated documentation for an API, take advantage of autocomplete, these sorts of things. GraphQL Playground is similar to Graphical, if you've seen Graphical, and there's also a newer type of tool in this area called Apollo Studio as well, that ships with Apollo Server. So these are all similar tools, but in today's session, we'll be using GraphQL Playground. Okay, so that's enough of me talking for now. Let's switch over to do something a bit more hands-on. So we're going to take a look at an existing GraphQL API that has data about movies and reviews of those movies, just to get us familiar with writing GraphQL queries and using GraphQL Playground. So we're going to go to movies.neo4j-graphql.com, and this will open up GraphQL Playground. You won't have this query, so yours will look more like this. So this is GraphQL Playground, which is that tool I mentioned that allows us to look at the documentation for a GraphQL API. So here we can see the entry points for queries and mutations. These mutations won't actually work because the database user that this is connected to doesn't have write permissions. So don't bother with the mutations. They're just kind of here for reference. But take a look at the queries and the data that we can get back. So we can see we have a movies entry point. We can see the fields that are available on the movie type. And then we can also see how we can traverse this data graph. So movies has an actors field that shows us the actors of the movie. And then we can also see other movies that those actors acted in and so on. So let's pause here and take a few moments to run a couple of these GraphQL queries. So I have some examples here, but you can sort of write your own here. So just explore GraphQL Playground a little bit and take advantage of the control space autocomplete functionality. Notice how we get back different fields as we add those to our selection set here. So we'll pause for just a couple of minutes, go ahead and open up GraphQL Playground, take a look at the documentation and write some queries, modify some of the examples pasted here and see what you can get back. If anyone finds anything interesting, drop it in the chat and we can take a look at it. But we'll pause here for just a couple of minutes and I'll catch up in the chat while we're doing that. Okay, so we're coming up on the 30-minute mark, which is about roughly the time we want to spend on each one of these 4 modules. So hopefully everyone got a chance to familiarize themselves with using GraphQL Playground to write some GraphQL queries, get data back. Want to point out the autocomplete functionality that we get. So if I do a control space, I can see all of the fields available. And here I've added directors. So I'm bringing back the first 10 movies and the directors and some fields for each one of these movies. And the other thing we want to make sure that we are aware of is this docs tab, which shows us all of the data available, the fields for queries mutations, and then the fields available on each type. Cool. So this example GraphQL API was built using the Neo4j GraphQL library. Actually, I can share the code for this. Neo4j Graph examples. So the Neo4j Graph examples GitHub repo, or GitHub organization rather, has code samples for each one of the Neo4j Sandbox data sets. And so if you use Neo4j Sandbox, you've probably seen things like the recommendations, the movies, the Panama Papers, network operations data sets. And some of these have GraphQL examples for them. And this one that we looked at, the movies.neo4j-graphql.com example, that code is available here, which I will drop into the chat. There it is. So if you are curious how the code for this example API works, that code is on GitHub. Okay, so that was a bit of an overview about GraphQL, some of the tooling that's available, and some GraphQL concepts. What we want to do now is spend the rest of our time focused on building our own GraphQL APIs. And to do this, we are going to use Neo4j, specifically Neo4j Aura, and we are going to use the Neo4j GraphQL library to do that. So the first thing we'll need to do is create a Neo4j Aura instance. If you've already done this, that's great. You will need your connection string for the Neo4j Aura instance and the password for that, because we'll need to connect our GraphQL API to the Neo4j Aura instance. If you haven't done that, go ahead and do that now. So this slide kind of shows the steps here. So the first step is just to sign in. You can do that with like a Google or email. Alex dropped the link in the chat for Neo4j Aura. And then once you sign in, you'll be prompted to create a database. And there are two tiers of Neo4j Aura. There's the professional tier, which are for my sort of real world applications that I want to build and deploy. And for that, I can choose the size and scale of my database, but that I need to put in a credit card and pay money depending on the size of the instance that I provision. But then there's also the free tier, which has most of the same functionality as the professional tier. It's just limited on the size of the database that I can create, but it'll be perfectly fine for what we're going to do today. So just create that free tier instance, and that will provision your Aura instance. So let's go ahead and do that now. So we have access to that later on. So I'm going to go ahead and do this because I don't think I've created an Aura instance that is up and running. So I'm going to go to the Aura landing page and sign in. I guess I'm already signed in. So you would see like a sign-in box that allows you to sign in with Google or email or something like that. And the first time you sign in, you'll just be prompted to create a database and choose between professional and free. I want the free tier. I'm going to call this the Neo4j GraphQL workshop. And the free tier by default is deployed on Google Cloud, and I have a choice of just a couple of regions. There's other options for AWS and GCP in different regions as well on other tiers of Aura. I'm going to choose one that is closest to me in the US and click create free DB, and it tells me that I need to save this password. So we're going to copy that, save that somewhere off screen and say, yep, I've saved that somewhere. So we will need that password later. So be sure to save that somewhere handy. And then our database will take a couple of moments to provision. Once it's provisioned, we'll have the connection URI here, which we'll use to connect it to our GraphQL API. Okay, so let's take a moment. Go ahead and do that if you haven't already. We'll want to be able to use our Aura instance for the rest of the session. Oh yeah, and this is a good point. So someone's asking in the chat, should we have an empty database? Yeah, so if probably best to create a new database, or if you have an existing database, maybe to clear it out. Definitely. I don't think there would be any. We're going to create some data using GraphQL and then query that data. So if you have some existing data in there, it may not be a problem. But if you have some node labels that overlap with what we're going to use, that might be a bit awkward. So yeah, if you have data from previous workshops, go ahead and delete that. Okie doke. Well, let's talk a bit about the Neo4j GraphQL library, and then we'll jump into, again, another hands-on exercise where we're actually writing some code and connect it to our Aura instance. So the Neo4j GraphQL library is a JavaScript, so Node.js JavaScript library for building GraphQL APIs with Neo4j. So there are GraphQL implementations in lots of different languages. So I can build GraphQL APIs in general with Go, with Python, with Java, with JavaScript. But the Neo4j GraphQL library that we're going to use today is specifically for the Node.js JavaScript ecosystem. And sort of the fundamental goal of it is to make it as easy as possible to build GraphQL APIs backed by Neo4j. So this is all about building the API layer that sits in between the client and the database, and that API layer is going to be a Node.js application. So if we think of what are kind of the goals of the Neo4j GraphQL library, there are a few of them. One is to support this idea of GraphQL first development, where my GraphQL type definitions are then driving the database data model. So that means we don't need to maintain two separate schemas, one for the API and one for the database. Our type definitions are then used to generate the database data model. So you can think of this as kind of bringing the schema and the typed strictness of GraphQL to Neo4j, which is schema optional. So we don't actually have the concept of schema in the database itself. The other goal is once we've created these GraphQL type definitions, we're then auto-generating GraphQL API operations. So we write some type definitions that defines the data model that we want to work with. And then the Neo4j GraphQL library will generate query and mutation types, creating API entry points for each of these operations for each type. So create, update, delete, and read, so like a CRUD, full CRUD API. Also adding in things like ordering, pagination, complex filtering, including the native database types like date, time, and spatial as well. Then at query time, we talked about this idea of GraphQL resolvers, which are the functions that have the actual logic for going out to the database to the data layer and either fetching or creating that data. And with the Neo4j GraphQL library, we don't need to think about resolvers in most cases. We're going to be generating database queries at query time. So for any arbitrary GraphQL request that comes in, the Neo4j GraphQL library is going to generate a cipher statement and a single cipher statement. That's a really important aspect here to resolve that GraphQL operation. And the fact that the Neo4j GraphQL library is generating a single cipher statement means that we're avoiding that n+1 query problem. So for any arbitrary GraphQL request, that's a single round trip to the database with a single cipher query, which is a really important aspect for performance considerations in a couple of senses. One, that gets rid of the n+1 query problem where we're making multiple round trips to the database. We're not going to do that by generating a single database query. But then also graph databases like Neo4j are optimized for these kinds of nested traversals through a data graph that we often construct with GraphQL. So the Neo4j Cipher execution engine is then going to optimize that query to do this traversal through the data graph. That's the type of operations that graph databases are really, really good at. So we have benefit for performance there in a couple of aspects. Another goal of the Neo4j GraphQL library is to provide extensibility with Cipher. So we talked about the CRUD operations, create, read, update, and delete, the query and mutation fields that are generated. And that's good for creating data, updating data, and that sort of thing. But oftentimes we have more complex logic that we want to be able to express in our API. And Cipher, if you're familiar with Cipher, this is the query language that we use with Neo4j. Cipher is really, really powerful for expressing a lot of this custom logic, things that we can't express in GraphQL itself. So for that, there's a feature called the Cipher schema directive in the Neo4j GraphQL library. Now, a schema directive is like GraphQL's built-in extension mechanism, basically. So this is something we use in GraphQL type definitions. So in that SDL, the schema definition language, a directive is like an annotation on a type or on a field that says, hey, there's some custom server-side logic that is going to occur here. And the Cipher schema directive takes a Cipher statement and sort of binds that to the field that we are annotating. And it then allows us to define essentially a computed field where at query time, if I've included this field in the selection set, instead of going just to try to fetch that data from the database, I'm going to execute that Cipher statement that I've attached to the field and run that as a subquery in the generated Cipher statement. So this allows us to attach custom logic using defined in Cipher in our GraphQL type definitions. So the example here is a recommended field for a business. So maybe this is like on the business type itself. So if I like this business, what are other businesses I might be interested in? And this is returning an array of business nodes here. So we've written the Cipher statement that's going to start from the business being resolved. So if you like the business you're currently looking at, let's find users who reviewed this business. What are other businesses that those users reviewed? You might be interested in those. So kind of a simplified collaborative filtering recommendation query, which we can express in Cipher through this graph traversal. We're not going to talk too much about Cipher. We'll look a little bit at modifying some Cipher queries. If you're not familiar with Cipher, you can think of Cipher as a graph pattern matching language where we're drawing this sort of ASCII art notation. So you can see here, we're drawing sort of a node around this. So this represents the business that we're currently resolving. And then the arrows represent relationships. And the brackets are the type of the relationship. So you can see here, we're kind of drawing this ASCII art representation that represents this traversal from a business to the review, to the user who wrote the review, to other reviews that the user has written of other businesses. So that's Cypher. If you're not familiar with Cypher, the session on Monday that Lou did on Intro to Neo4j would be a great one to catch up on. But anyway, so that's one of the goals of the Neo4j GraphQL library, is to allow for defining this custom logic with Cypher. That is probably my favorite feature of the Neo4j GraphQL library if I had to pick one. So we're not going to go through installation and running this locally because we're going to use the Codesandbox starters in a second here. But I want to talk a little bit just about how would I get started with the Neo4j GraphQL library. So we said this is a JavaScript, so Node.js JavaScript application that we're building. That is our GraphQL API. And so we first need to install a few dependencies. One is the Neo4j GraphQL library itself. We also need to install the JavaScript GraphQL implementation, the Neo4j JavaScript driver. So the driver is what we use to actually connect to and execute Cypher queries against Neo4j. And then in this case, we're installing Apollo server, which allows us to create Node.js GraphQL APIs. We could use other JavaScript GraphQL server implementations, but Apollo server is, I think, probably the most popular in the ecosystem. Now, what Apollo server typically does is takes GraphQL type definitions and GraphQL resolver functions, combines those together into what's called a GraphQL executable schema object, and then serves that over HTTP and executes queries against that schema as they come in. But we said with the Neo4j GraphQL library, there are no resolvers. We don't write these resolver functions. So instead, what we're going to do is use the Neo4j GraphQL library to generate one of these GraphQL executable schema objects, and then hand that to Apollo server to serve over the network and handle the GraphQL requests as they come in. So a typical setup for using the Neo4j GraphQL library might look like this. We're going to import the Neo4j GraphQL class. We're going to bring in the Neo4j JavaScript driver, and we're going to bring in Apollo server. We write our GraphQL type definitions using SDL. Here we have movie and genre. Note here that we have this relationship schema directive. We'll talk about this in a bit more detail, but the relationship schema directive here captures the direction and type of the relationships in the property graph. So in the property graph model, all relationships have a type and direction. In the GraphQL world, we don't necessarily have a direction associated with a relationship. So this relationship directive allows us to capture that additional information to generate our property graph model from these type definitions. We then connect our driver instance to Neo4j. This is where we pass in our connection credentials. In this case, this is just the default local instance, but we would typically point this at Neo4j Aura or some database hosted in the cloud. Then we pass these type definitions and the driver instance to the Neo4j GraphQL constructor to create a new Neo4j schema and pass that to Apollo server that's then going to serve our GraphQL schema over the network. So that's the basic structure of what this would look like. Notice that we didn't have to write any resolver functions. We didn't have to specify how to actually write Cypher queries to fetch data from the database. We just generated that schema from the Neo4j GraphQL library. And then, of course, we would start the GraphQL server with a command like this. And by default, if we open in a web browser, this would run on like port 4000 localhost, something like that. If by default, if we open that in a web browser, we'll see GraphQL Playground, or with version 3 of Apollo server, we would see Apollo Studio, which is similar, but that in-browser IDE functionality for querying our GraphQL API. Okay, so that's the basic structure. We want to work with a little more complex of a data model. And so we are going to work with a like online bookstore API today. So we've already gone through, I say someone before we got started here already went through the process of defining the graph data model. The data modeling process, this is kind of an iterative process, but basically you start with the requirements for your application. Think about, okay, what are the entities? These become nodes. What are the attributes of these entities? These become properties. How are they connected? Those are relationships. And then we think, well, can we think of traversals through the graph that answer the questions needed for our business requirements? If we can, then we're done and we have our data model. If we can't, then we need to iterate a little bit and adjust our model so that we can answer the questions that we have for our business requirements by traversing the graph. So that's the basic structure. We've done this already for an online bookstore. Let's see if I have a larger, no, can I zoom in a bit? No, can't zoom in a bit. This is the data model that we've come up with here, where we have books. Books have reviews that a customer wrote. Customers place an order. Order contains books. Books have an author and a subject. And then our order has a shipping address. So that's the basic data model that we're going to work with. And that is already has already been created in a Codesandbox environment for us. So what we're going to do is open this Codesandbox link, and this will be in the slides. If you have the slides, this is what slide are we on? Slide 29, but I'll also paste it in the chat here. The link is quite long. Let's find the chat. That's the Q&A. Here we go. So that's the link that we want. And this will open up a Codesandbox. You may see something a bit different. I think yours may look something like this. I think it saved my previous connection credentials. Or maybe it has those as default. I'm not sure if you have those or not, but we're going to replace those anyway. But let's talk about Codesandbox for a minute here. So Codesandbox is really nice because it allows us to run, let's see if I can make this a bit bigger. Don't show toolbar in full screen, there we go. Codesandbox allows us to run JavaScript, and in this case, Node code in the browser. And we have this sort of editor. I'm just going to delete whatever we have here, since that's from a previous one. Don't need to see that. So the code that we're running, if we take a look here at, let's start at package.json, and we can see the dependencies we're bringing in, the Neo4j GraphQL library, Apollo server, .env, this is just for setting environment variables, the GraphQL, the JavaScript GraphQL implementation, the Neo4j JavaScript driver, and then NodeMon, this just allows us to restart the application when we save any changes. So those are the dependencies that have already been installed. And then if we look at index.js, this is going to look very similar to the quick start structure that we saw before, where we're bringing in the Neo4j GraphQL library, bringing in Apollo server, and the Neo4j JavaScript driver. There's a couple of extra things that we're doing here. One is reading environment variables from this .env file. So the first thing we're going to need to do to make this work is populate this with our Neo4j Aura credentials. Otherwise, we won't actually be able to connect to our Neo4j Aura instance. Then the other thing that's going on here is we're reading the type defs from this schema.graphql file. So there's a schema.graphql file that has our GraphQL type definitions. And these GraphQL type definitions, these match the graph data model that we saw in the previous slide with the data model for the online bookstore. So we'll go through this in a minute. Let's look at the rest of our index.js file. Then we're passing those type definitions to the Neo4j GraphQL library, creating a new Neo schema instance. We're creating a Neo4j driver instance. And here's where we're reading these environment variables that we're setting in the .env file. So these environment variables, the connection credentials for our Neo4j Aura instance, are being read from this .env file, which we haven't set quite yet. And then we're passing that off to Apollo server, passing off the schema. And here we've injected the driver instance into the context object. We can do that, or we can also just pass the driver instance here when we create the Neo4j GraphQL schema object. Either one of those options works. And then we're starting the server, the GraphQL server, and Codesandbox gives us in the right pane a web browser that has, in this case, GraphQL Playground running. So we can see the documentation tab. We can also, if we want more screen real estate, we can copy this URL and I guess I do need my toolbar, and open that in a new tab. And then we have full screen GraphQL Playground for the Codesandbox instance. But if we try to run a query, so the exercise says, open the Codesandbox, add your, this says Neo4j Sandbox, this is the Neo4j Aura connection details to the .env file. You'll need to sign into Codesandbox to save your updates, yes. And then in GraphQL Playground, running in Codesandbox, we want to run this GraphQL query to just search for books and the title of our books. So even though we have GraphQL Playground, if we run that query and say books title and click play, some things happen. So one thing to notice here is that in the console, we've logged the generated cipher statement. So we said that the Neo4j GraphQL library generates a cipher statement for any arbitrary GraphQL request. And we've turned on debug mode for the Neo4j GraphQL library. So one thing that we get in the logs is the generated cipher statement. I like to have debug mode on because I like to just kind of see what's happening. And of course, we get an error that says we couldn't connect to the Neo4j instance because I think the values that I had in here before that instance is no longer around. So we get an error, that's fine. The way that we enable debug mode, by the way, in package.json, you can see here when we're running npm start, before we're starting our GraphQL API application, we're setting this debug environment variable. And if we take a look in the docs, so should have the docs pulled up anyway, /docs, GraphQL manual. If we look in the troubleshooting section, here's where we're talking about how to enable debug mode. So I'll drop a link to that in the chat as well. That's a useful feature. But the docs in general are here, which talks about all of the features of the Neo4j GraphQL library in a lot more detail. So a lot of things that we actually won't have time to cover today. Okay, so that's how Codesandbox works. So in this case, I'm going to click fork. So I need to fork this because I own this, and if I don't fork it, then I think my changes will overwrite everyone else's. But for everyone else, once you start to edit this and then go to save, you'll be prompted to sign in to Codesandbox, which you can sign in with GitHub, or I don't know, maybe like sign in with Google or something, not sure the sign in options. But you'll want to sign in to Codesandbox because then only you will be able to make edits to that Codesandbox instance. So to follow along, you'll want to sign in and then fork or save a copy with your changes. So the first thing we want to do here is add our Neo4j Aura connection details to this .env file. So the Neo4j URI, password, and the user. So let's go back to the Neo4j Aura console. So here, make this a bit bigger. Yeah, there we go. So this is the console application for Neo4j Aura. So this is where we created a Neo4j instance previously. And I'm going to click this copy icon. So this is the connection string. Yours will be different. So be sure to copy yours. And we'll paste that in the Neo4j URI. The Neo4j user, the default user is Neo4j. And then hopefully we all saved our passwords. Hopefully I saved mine. There it is. So I'm going to copy mine from where I saved that, paste that here, and then click on this hamburger menu, file, save. And if you're not signed in, this is where you'll be prompted to sign into Codesandbox, which will then fork that starter Codesandbox that we had and then allow you to make changes to your own. And now, when I go back to GraphQL Playground, and if I say, let's start with the books query field and give me the title of each book. Well, I don't get an error, I get back an empty array. If we scroll down to the bottom of the console, you can see, yep, execute successful, received 0 records. Here's the query that we executed. I can add more fields. And as I add more fields, I can see that those start to show up in the generated cipher query. So, okay, this works. I'm connected to my Neo4j Aura instance. I'm not getting any data back, but that's expected because the database is empty. So that's what I should expect. If you have data in your database already, let's take a look at how to clear that out. So back in the Aura console, I have this open with dropdown. I can choose Neo4j browser, or I can choose Neo4j Bloom. Bloom is really cool. It's like a graph visualization tool for exploring the graph visually. We're going to use Neo4j browser though. And I'll need my password again here. So username is going to be Neo4j, and the password is the password that was generated for us when we created our Aura instance. And here I can write cipher queries. So let's say match A, return A. So this is a cipher statement that's going to match on all results in the database and return them. We should probably do something more like this, count, just return a count. This is going to tell us how many nodes we have in the database. We don't have any. If we did, we could match A and detach, delete A. So this statement, be very careful when you run this because you will delete everything in the database. So be sure that you're connected to the right database that you want to delete to remove all your records before you run this. But this is the command, the cipher statement to run to delete any data that you have from previous workshops before we move forward. So that one's optional. You may not need to do that. If you create a new Aura instance, it will be blank. But okay, let's pause here for just a couple of moments. If you have issues, drop a link in the Q&A or in the chat, and we'll try to figure out what's going on there. But hopefully everyone is able to open up that Codesandbox link, update the .env file with your Neo4j Aura connection credentials, and then run this GraphQL query that will return no results. And if you just get an empty array and no error, then you should be good to go. So we'll pause here for just a couple moments. Let us know in the chat also if you are good to move forward as well. It's good just to take a poll of where everyone is. And so I see a few comments in the chat saying they were getting errors like no, unable to perform discovery, or no routing servers available. So make sure that the connection, where's my .env file, make sure that the structure of Neo4j URI matches this format. So Neo4j plus s : / and then some numbers .databases.neo4j.io. So if you're getting some error about no routing servers available, cannot perform discovery, make sure that one, I guess that your Neo4j Aura instance is up and running, and that you've copied exactly this connection URI. Okay, a few folks say that they're good. Okay. Yeah, and also, so I see a couple of folks saying that they're using a local Neo4j instance. So you won't be able to use a local Neo4j instance because this Codesandbox instance is connecting over the network. So you'll have to use a Neo4j Aura instance or Neo4j Sandbox, something like that. But you will not, this Codesandbox setup will not be able to connect to a local Neo4j instance. Okay, so let's press on. Sounds like, looks like most folks are good to go. Okay, cool. If you weren't able to get this running, you can keep trying to get this set up. I'm just going to talk a bit about some of the features of the Neo4j GraphQL library before moving on here. So we talked about the property graph model, how we sort of generate that through this iterative modeling process where we start with the business requirements and we sort of identify the nodes, how the nodes are connected, those become relationships, and so on. And what we've then done is generated GraphQL type definitions that map the graph model that we identified through this modeling process. So the convention with the Neo4j GraphQL library is that GraphQL types map to node labels. So here we have the order type in our GraphQL type definitions that maps to the order node label. And fields in GraphQL map to properties, or I say scalar fields map to properties on the node. Object fields and array of object fields map to relationships in the property graph model. So here on order, where we have a ship to field that is a relationship to an address type, that maps to this ships to relationship in the property graph model. One thing that's really handy to use when you're going through this modeling process is the arrows application. I'll drop a link to this in the chat. So arrows, this is not the current project we're working with. This is, I think, from a previous one. But arrows allows us to draw these diagrams. So I can draw these visually and attach labels, user. This is another user, and I am friends with this user, this sort of thing. So this allows me to kind of draw these diagrams. And then one kind of nifty convenience feature here is in the export, I can select GraphQL. Oh, I need a username here. So in GraphQL, we need to have at least one field for each type. There we go. So if I select GraphQL in the export option, it will generate the GraphQL type definitions that work with the Neo4j GraphQL library, which is quite neat, including the relationship schema directives as well, which is nice. Okay, so we talked about the relationship schema directive that we use to capture the relationship type and the direction. There are some other schema directives that we use with the Neo4j GraphQL library as well. We mentioned the Cypher schema directive previously, which we'll talk about. in a bit more detail. But here we're making use of some other schema directives that are quite handy. So one is the timestamp directive. And by the way, if you look in Codesandbox in the schema.graphql file, that's where you will see these GraphQL type definitions that we're looking at. So the timestamp directive, this is used to indicate that when I create this node, I want that value to be automatically set. So here for the order, when I create the order node, I just want to, on the server, set the value for the timestamp of when it was created. Similar for ID. So the ID directive on a field indicates that this is a unique identifier, and when that node is created, to automatically set that value. So I don't need to pass values for those in the GraphQL query. There are lots of other GraphQL schema directives that are available in the Neo4j GraphQL library. If we open up the docs, we can see what a lot of those are. So something good to be aware of. Okay, so let's take a look at creating data. So we ran that one query that was looking for all of the books and just gave us an empty array, which was not very exciting. So let's switch back to our Codesandbox API. So I'm just going to move GraphQL Playground over a bit more. You can also open this in another tab. I'm going to leave this in the current tab because I like to see the generated cipher in the logs here. But you can copy this link and open that in a new tab to have GraphQL Playground on its own. So if we look in the docs and if we scroll down, let's make that a bit smaller. There we go. If we scroll down to mutations, we can see that there are generated mutations, different operations for each type. So create orders, delete orders, update orders, similar for customers, addresses, and so on for each type that we've defined. So let's start off with creating some book nodes. So we'll say, let's create books. And this takes an input object or an array of input objects. So we can create multiple books. Let's just try one here. So the input, every book has some ID. I'm going to create the graph algorithms book node. We have a price and has a description, practical examples in Apache Spark and Neo4j. Okay, and then we need our selection set, which is going to give us the books that were created. So I run this, and it gets back that yes, you created the book graph algorithms. If I look at the generated cipher statement here, we can see that we are creating a book, setting some property values, passing some parameters. And we can verify that if we go back to our Neo4j browser and query for books, we can see, yep, we've created one node for the graph algorithms book. Okay, that's fine. Let's create a review for this book. So we'll execute another mutation. It's going to be create reviews. that will take an input object. And the review has a rating. We're going to give this 5 stars. Review has text. I'll say best use of graph algorithms for this book. And then the review is connected to a book. So we can create the review node and the relationship connecting the review and the book in the single operation. So we're going to say for the book field, we can either create a book or connect to an existing book. So this concept is called a nested mutation, where we can do multiple operations in one mutation, which is really powerful because we can actually create fairly complex subgraphs in a single mutation operation. But I'm going to choose connect because we want to create a relationship from this review to an already existing book. And the way we're going to connect is using the where filter. So we're going to say where the node title is graph algorithms. Then we need a selection set. So it'll give us the reviews that we created. Let's bring in the rating, the text of the review, the book title, and then also every review has a created at timestamp. So we run that and we get back, here's the rating and the text, here's the title of the book that this review is connected to, and we also get back this timestamp for created at, even though we didn't pass a created at value in this input object. Well, that's because we put that timestamp directive on the, that's the order. We also placed a timestamp on the created at field on the review object. And so that means that anytime we create a review node, we're going to set the value server side of when that node was created. By default, so just the timestamp, they will also, I guess, update the timestamp for any update operations as well. But we can specify that we just want that for the created operation. Okay, and if we now go to Neo4j browser and we double click on this book node, we can see that, yep, now we have a review connected to the book node that we've created with GraphQL. Cool. So we saw this concept of nested mutations where we have that connect or create. We can do this in much more complex structures. So I'm just going to copy this query so you don't have to watch me type this. Oops, we hibernated. Let's refresh that. I'm going to move this into a full tab so we can see the query a bit better. And our code sandbox went to sleep, it looks like. So that'll take a second to reload. There we go. Oh, that's not the query. This is the query. And we'll make this a bit bigger. So here's a more complex nested mutation. So I'm starting off creating a customer, and customer has just a username, but that customer can write some reviews, That customer can have orders. So I'm going to create an order for this customer. I'm going to connect that to an already existing book, the Graph Algorithms book. And then every order needs a address. So now for the ship to address, we're going to create a new node that will be an address node that has the address and the latitude and longitude for where we want to ship this book. So now I've created a more complex structure in a single GraphQL operation, something that looks like this in the graph. I've created a customer, created a review, created an order, connected that to an already existing book, and created a new shipping address. So we can create much more complex structures with these nested mutations. Okay, so if you were following along, let's clear out the database because we're going to run a different mutation to create some sample data. So in Neo4j browser, let's run that match A, detach delete A to delete everything. If you weren't following with those mutations, don't need to worry about that. Your database will be empty. But now let's load some sample data. So in the slides, this is slide 38. I'm going to copy this query, and this is kind of a long one, but this is going to create the sample data that we're going to work with here. So here we're creating 3 books, a couple of customers, and some orders for those customers. If we look in Neo4j browser, we can just match on everything and return it. If we want to see what the graph view of this looks like, it should look something like this, where we have a few different books, we have a few different orders, and a few different customers that have placed those different orders. So copy this query out of the slides, that's slide 38, run that in Codesandbox, and then we'll take a look at how we can use some of the generated queries that we have available in the Neo4j GraphQL library to query this sample data. So I'll pause for just a moment or two. Yeah, so it looks like, looking at the chat here, it looks like a few folks had issues. Some folks were able to refresh the sandbox or try to fork it again. It sounds like that is working for most folks. Great. Let me try. I don't know if the chat will cooperate here, but I'll paste this long mutation in the chat. We'll see if it gets cut off or not. If you don't have the slides up, maybe that's easy. Yeah, it looks like that works. So that's ugly, but it's in there. If you want to just copy that mutation out of the chat, I think that'll work. But best to have the slides open. You can just get it from the slides. Okay, cool. So hopefully everyone was able to run that mutation and have the sample data loaded. So now what we're going to do is take a look at some of the generated operations in the Neo4j GraphQL library to see how we can query this data that we've now created in the database with that big nested mutation. So by default, we have a query field, so an entry point into the API that is generated for each type that we've defined. We can, of course, configure this if we don't want to expose query fields for certain types. There's a whole section on authorization as well that we can add as well if we maybe want to have some types that are protected, this sort of thing. But by default, we have an entry point, a query field for each type that we've defined, and then we can specify what fields to bring back, how to traverse the data graph using the selection set concept. So as we add more fields, those fields are then included in the generated Cypher query that comes back, and we get the fields that we've requested in the selection set. We also have sorting and pagination arguments that are available as well. So these are in the options argument. So here in this example, we are sorting all books by price descending and then returning the first one. So what's the most expensive book? And that happens to be our graph algorithms book. So we can use, and notice we also have the offset argument here is 0. So limit 1, offset 0 means give me the first one. We can use this combination of limit and offset to paginate. So we can do offset-based pagination. So in this case, we would increment offset by the number of objects that we're returning in the limit to give us the next page. And we wonder, how do we get the total number in this case? I don't have the example here, but there is a count query that is also generated for each type as well. So here, books count means I have 3 total books. So if I'm showing just one at a time, well, then I can calculate on the client that I'm going to have 3 pages to fetch. So that's offset-based pagination. We can also use cursor-based pagination with relationship fields. And this is using the relay style connection types. So on these relationship fields, you'll see that there is a connection type field available as well. So actually, this is one worth looking at an example for rather than talking about. So let's start off here looking for orders and order ID. So I'm going to just grab an order ID for one of these orders. So let's filter for just one order where order ID is this value. And you'll see that I have books, the books field, and I can just traverse that relationship to find whatever books are included in this order. But I also have a books connection field that will give me the relay style connection type. So if you're familiar with relay, so relay is a GraphQL client, but there is also a relay specification for connection cursors, I think it's called, commonly called relay spec. And this specification defines the relay connection type, which allows us to basically attach metadata in a relationship field. So things like the total count, and then we have edges here. And in this case, the edges are going to be the books. But then we also, in addition to total count, have a page info. object. And the page info, this is going to tell us for the purposes of pagination, if there is another page, and then what the cursor is. This one is going to be not very exciting because there's only one book. So has next page is false. But if this order had multiple books, then has next page would be true if I did something like give me the first, I don't know, the first two here or something like that. Then if I had another page, I would, and in my next query for the next page, I would grab this cursor and I would say, give me the next page after this cursor. And that would allow me to paginate using these cursors rather than using the offset method. And this relay connection type is also powerful for handling relationship properties as well, which is the other way that we use the relay connection type in the Neo4j GraphQL library. Okay, so that is pagination. Filtering, so the where argument includes a whole bunch of filter options. So here we're searching for books where the price is less than $20, but we can also filter on string fields using any of the string comparison operators. We can do filtering on point fields using the distance function. So show me all points within 1 kilometer of some other point, this sorts of things. So lots of options there for filtering. Filtering can be applied at the root or nested in the selection set. So here we're searching for all books that are less than $20, and then for all of the reviews of these books, only show me the reviews that were created after January 1st, 2021. So the filters are applied at the level in the selection set where you include them. Here's an example using geodistance filtering. So here we're searching for all addresses that are within 1 kilometer of a certain point. Now, we said earlier that the filters are applied at the level of the selection where you include them in the argument. But what if I want to say filter for orders that were sent to an address that are within 1 kilometer of a certain point? Well, the order is its own node. So that means I need to use filtering using relationships because I want the filter to be applied at the root. I only want to see the order if the address that it's connected to matches the filter, in this case, 1 kilometer of a certain point. So what I'm going to do is use relationships to filter. So I'm going to say where the ship to location is less than, distance is less than 1 kilometer from this point. And that will apply the filter at the root, but using this sort of nested structure in the relationships. Okay, so here's our next exercise, which is to update the GraphQL schema to include author and subject. So we left author and subject out of our example that we started with. So we want to add those to the schema and then run GraphQL mutations to add the author and subject to the graph. So let's see, we're a bit behind on time here. So I think maybe what we'll do is I'll just go through the solution for this so we can see how this works. And then maybe talk about some of the topics that we won't have time to get through, which will be adding custom logic and authorization. So let's go ahead and just jump into the solution for this one. So if we take a look at our Codesandbox, and if we take a look at our GraphQL schema, we can see here that we don't have author and we don't have a subject type. So we want to include that in our schema that was included in our graph model that we created. So let's update our type definitions to include that. So we'll do a couple things. Let's create a couple of new types here. So type author. So remember we said that any types that we define in GraphQL are going to map to node labels in our property graph model. So an author is going to have a name, and that's going to be a string. I can make that a required field. So this exclamation here, this means that this is a non-nullable field, so that I have to have a name field specified in order to create this author node. If I leave that off, then I'm saying that's a nullable field. But since it's the only field that we're going to have for author, let's make that required. And then an author is going to be connected to a book. So let's have, we'll call it books, because an author can have written more than one book. So that will be a object array field to represent that one-to-many relationship. And then we're going to use the relationship directive to capture the type of the relationship. Let's call this author of. And then we also need the direction, which is going to be going out. So the author is the author of a book, so it's going to be an outgoing relationship. And then we'll create another type for the subject node. Subject will also just have a name. And similarly, the subject node will be connected to one or more books. And we'll also create a relationship field, a relationship directive to specify the subject. We'll say about. So a book will be about a subject. So in this case, that's going to be an incoming relationship. And then on the book type, we want to be able to traverse from the book to the subject and the book to the author. But right now we can't do that. We can go from the author to the books that they've written, or from the subject that is connected to books. But we need to add those relationship fields to the book type if we want to be able to traverse from the book to the author or to the subject. So we'll make this authors, because a book can have more than one author. So this will be an object array field for author. And we'll add the relationship directive to capture the relationship type. And in this case, the direction is going to be in, because an author is an author of a book. So the relationship is direction coming in. And then similar for subjects, a book can have more than one subject. So that will be an object array field. And we'll capture the type of the relationship in a relationship directive. And in this case, the relationship is going to be out, because a book is about a subject, so it's going out. Okay, so we'll save that. And this will restart our API. And if I might need to refresh this to update the docs tab. So we should see authors. Yep, we've got authors and subjects now. Cool. So now what we need to do is write the GraphQL mutations to add authors and subjects to the graph according to this table. So we want to create the author Marty Kagan, who wrote the book Inspired, Winston Graham wrote the book Ross Poldark, and Mark and Amy wrote Graph Algorithms. So let's see if we can write those mutations real quick here. Make this a bit smaller to give us a bit more room so we can see what we're doing. So there are a few different ways we could do this. I think we'll start with the create authors. That's probably the simplest way to do that. We could also do an update book mutation, and then using the nested structure, do a create operation within the update book. But let's start with this create authors approach first. So that's going to take an input object. Previously, we just passed a single input object, but we can also pass an array of input objects, which we're going to do here to create Marty Kagan wrote the books. And here I have the option to create a new book or connect to an existing. I'm going to connect to an existing where the node title of the book is he wrote Inspired. And then we're going to do something similar for Winston Graham. Again, connecting to an existing book where the node title is Ross Poldark. Ross Poldark is not the author. Ross Poldark is the title of the book. A great love story. If you haven't seen it, haven't read the book. Okay, we're creating authors. So let's see what we created. Let's give the name of each author and then the book title. I'm going to skip the other two here because we're kind of running out on time and they're similar operations. So okay, we've created these two authors, connected them to the books. If we jump now into Neo4j browser, and if we select author, you can see here's Marty Kagan, here's the book Inspired, here's an order for that book, here's the author Winston Graham, connected to the book Ross Poldark, was also in this same order. Cool, so that's what we wanted. I'm going to skip the subjects because that's a similar idea. The solutions are linked here in this code sandbox if you want to take a look at that as well. Okay, so we are a bit out of time here. There are some topics we didn't get to. So in the last 10 minutes or so that we have here, let's talk a little bit about some of the topics that we didn't get to. And again, all the content for this training is available in these slides. And there's also the Graph Academy training, which has this content plus a bit more that you can take as well. You also get a certificate for that one. But let's talk through this a little bit. So adding custom logic. There are two ways to add custom logic to a GraphQL API that we've created using the Neo4j GraphQL library. One is the Cipher schema directive. The other is by implementing custom resolvers. So if you're following along, what we were going to do here is open a new sandbox that has some examples of custom logic in the schema, and then start with some new sample data, but we'll skip that. So these two approaches for adding custom logic, the Cypher schema directive is the, I don't want to call it the easier approach, but it's the approach that has higher, we'll call it developer productivity. I guess there's sort of less boilerplate to write in this case, where I'm just attaching a Cypher statement to a field in my GraphQL schema, whereas with Custom Resolver, I actually have to write a function, connect to the database, and execute some logic. It's important to note also that with the Cypher schema directive, that Cypher statement, the custom Cypher statement that I attach to the schema, that's still included in my single generated database query. So I'm still only making one round trip to the database, whereas with a custom resolver, that resolver is then going to be called in a nested fashion, and any logic that I'm doing going out to the database or something like that, that happens after my generated Cypher statement runs, and perhaps another round trip to the database that will have performance implications. So something to think about there. But if you're calling out to another service or something like that, maybe that's a good case to use the custom resolver. So here's an example of using the Cypher directive on a computed scalar field. So here we're extending the order type to add a field. This extend keyword in GraphQL SDL just allows us to add additional fields, extend the type. We could also just include this field along with the other fields that I've defined on the order type, but this is just nice to sort of single this out. So here we're adding a subtotal field that is going to be a float, and we're calculating this in Cypher. So we're looking at all of the books that are contained in the order and summing up the price. So in these Cypher directive fields, there's a Cypher variable that is defined called this, that refers to the currently resolved object. So in this case, it refers to the currently resolved order. So I'm traversing out from this order to find all books that are contained in the order, calculating the subtotal. And then I can include that in my selection set as normal, and I get that field back. It's important to point out here that the client of the API doesn't really have any idea that this is a Cypher directive field. So it's opaque to the client of the API that this is a special computed field, which is quite nice. We can also use the Cypher directive on node and object fields. So here we're returning recommended books for a customer. So this is similar to that query we saw before with businesses, where we were generating queries based on a collaborative filtering query, where what are other users who liked this book? What books do they read? I might be interested in those, that kind of thing. And we're returning a node from the Cypher query. And we can then use that recommended field, which will just resolve to books, and we have all of the other fields on the book type that we would expect. Any field arguments that we define on the field that has a Cypher directive are passed to the Cypher statement as parameters, as Cypher parameters. So here we've added a limit field argument to this recommended field with a default value of 3. And then we can reference that here in the return clause. By default, this will be 3. If at query time we specify a different one, here we're specifying 1, then that value is always passed through to the Cypher statement. So this is useful for things like more complex, maybe search and filtering that we want to do. We can also return object fields. So here in this case, we're calling out to a third-party weather API using APOC load JSON. So APOC, if you're not familiar, is the standard library for Cypher that includes a bunch of additional functionality. One of those is to make JSON requests to other like JSON APIs. And we're returning an object that maps to a new type that we've defined called weather that has things like temperature and wind speed and so on. So this weather node does not exist in the database. It is just being returned from a Cypher query. We can also use Cypher directed fields on custom query and mutation fields. So in this example, we're using a full text index to implement a book search query field. This is nice for things like fuzzy matching and misspellings, that kind of thing. And then for a mutation field, maybe we have some custom creation logic. We want to take advantage of merging on various values. We can define that in a custom mutation field. And then again, any field arguments that we've defined on that mutation field are passed to the Cypher query as Cypher parameters. Custom resolvers, we need to add the ignore directive on any fields that we're implementing custom resolvers for to tell the Neo4j GraphQL library not to try to fetch that data from the database, and instead we're going to call this resolver function. And then if you've written a resolver function before for a GraphQL API, it's very similar to that. We can have any sort of logic in that resolver function. We can call out to another API, another service. We can use the Neo4j driver to handle the connection to Neo4j ourselves. The driver object will be available in the context object, which is passed to each resolver. In this case, we're just generating some random data just as kind of a placeholder to show how that works. Okay, we'll skip this exercise, leave that as something to do at home. And then really quickly, I will just point out some of the authorization functionality that is included in the Neo4j GraphQL library. So the authorization functionality is done using this auth schema directive using JSON Web Tokens. So to make authenticated requests to the GraphQL endpoint built using the Neo4j GraphQL library, the convention is that a JSON Web Token will be included in the authorization header. If you're not familiar with JSON Web Token, it's basically a way to cryptographically sign a JSON payload. So anyone can read the payload that's in a JSON Web Token, but it's signed with a special key so that with public-private key pair, you can verify that it was actually created by who it was supposed to be created by the application that should have issued the token. So this allows us to make sure that someone isn't just passing fake credentials with a fake token, that they actually are who they say they are. So this auth directive, this is another schema directive that we use to, in this case, define authorization rules in our GraphQL schema. And there are a number of different types of rules that we can define. We're about out of time here, so I'll just mention what those rules are and then point to some resources where we can find more about those. So the first rule is just is authenticated. And so this just means that to access this type field, the GraphQL request needs to have a valid signed JSON Web Token. If it doesn't, then you get an unauthorized or unauthenticated error. And you can see here that request on the left, we didn't add the authorization header. On the right, we added the authorization header with the appropriate signed JSON Web Token. Roles This is the next rule that we can define with the auth directive. And roles allow us to say, in order to do a specific operation or to access certain types or fields, the token needs to have a certain role. So you maybe need to be an admin role or something like that to create or update a new book. The allow directive is a bit more complex, and this is where we're actually comparing values in the JSON Web Token to values in the database. So in this example, we're saying that only a user can access their own orders. So in order to view an order, your jwt.sub, so the sub claim, this is the subscriber, this is like the identity piece of the payloads. This would be like the user ID or something like that. So a user can only see their own orders is what this rule is saying. And in this case, on the left, we're authenticated as booklover123, and we're trying to view all of the orders. And we get an error because, well, some of those orders are going to be placed by other users. You can't see those. On the right, we're authenticated as user Emil Eifram 7474, and we've included in the GraphQL query a filter to only show me orders for this user, and that works. We can see the orders for user Emil Eifram 7474. Now, of course, we also probably want to allow admins to have access to view all orders as well. So we can add a clause here that says, if your role is admin, then you can also see the order. Now, the problem in this example here, where booklover123 is trying to get all orders and they get an error, well, it'd be nice if we had a way to filter for the orders that they actually had access to. And that's where the where rule comes in. The where rule will actually inject a filter in the database query to only filter for the results the user should have access to according to how we've defined the rule. So here we're saying for the customer type, only allow access where the username matches the sub claim in the JSON Web Token. So only allow a user to have access to their own customer node. And that way, we can just execute a query that does not include the filter for customer username, just says, give me all customers and their username and their orders. And because we've defined this where rule, we're only going to show the currently authenticated customer. So in this case, we're authenticated as Emil Eifram 7474, and that's the only customer data that we get back. Bind is a rule that allows us to specify data that must exist when we are creating or updating the graph. In this case, we're saying that for a review, that when a review is created or updated, the author of the review needs to match the currently authenticated user. So I can't update or create a review that another user authored. I can only create and update reviews where the currently authenticated user is the author. We can also use the auth directive on cipher directive fields. So where we have custom cipher logic in two ways. One is the is authenticated, and then we also have access to the JWT payload values in the cipher query, which are passed in this auth cipher parameter. auth.jwt.sub will give me the sub claim in the JSON Web Token. So here we've added a books for current user query field that has a is authenticated auth rule. So only authenticated users will be able to access this field. And then what this is doing is looking up the currently authenticated user in the database by matching on their username, where the username is the sub-claim from the JSON Web Token. So find the currently authenticated user, find the orders that they've placed, find the books that are in those orders, what subject are those books about, and then find other books that are in those same subjects, and those are going to be recommendations. So our recommendations are going to be, what books have you purchased? Here are some similar books that you may find interesting. And what's nice about this is we don't have to filter in the query for a user. That's handled in the schema. We're just going to look up recommended books for the currently authenticated user based on the subscriber claim in the JSON Web Token. Cool, so that's a really quick look at the authorization features. There's lots of, I think, really powerful features and functionality there. So we're gonna skip the exercise. We'll leave that for a home exercise. Cool, so that is all the material that we wanted to cover today. I know we rushed through those last couple of sections, but all the material is in this slide deck here, so you can work through that at your own pace. There are quite a few things we didn't have a chance to talk about that are listed here in the documentation that I've linked, specifically things like working with unions and interfaces. That's an important one. The Neo4j GraphQL OGM, where we're using GraphQL type definitions to define models, and then we have a programmatic OGM API for accessing the database is another interesting tool that's available to us. And then, of course, working with relationship properties in the property graph model with Neo4j GraphQL library. Cool. So here's some resources. I mentioned the link to the slides, the documentation for the library, and then check out the Graph Academy training, which is a self-paced online training that has material similar to what we covered today, but a few more sessions as well. And then if you're interested more in the full stack aspect of Neo4j and GraphQL, there is the Grand Stack Starter project, which includes React front-end as well as an example backend API.